It's review time. All right, so coming to you live from Strouch Casa. No kids, no dogs. Sorry, just me tonight. It's kind of late here at the Strouch house, but anyway, got the test here next to me on the other computer. Looking through some things. There's a lot of questions just about adaptations and how those adaptations can be passed on to offspring. Remember it's a lot about if the adaptation is favorable, if it's something that's going to help the species out, then that species is going to pass those on to their offspring. If it's something that's not a favorable trait, then that portion of the population, could die out. So really with this one, as you've hopefully noticed in class, it's a big kind of vocab chapter. There's just a lot of kind of vocabulary things, but we'll just go through kind of some sample questions here. Here's one. Frequency of traits which presently offer high adaptive value to a population may decrease in future generations if what happened? Well, if something has high adaptive value, then the conditions of the environment would need to change for that value to decrease. So there's kind of an example of one, kind of a backwards adaptation. Talking about like fossils and layers. So, the higher up the fossil is, the younger it is. So if there's fossils of one thing and then underneath it there's fossils of another, it's likely that the fossils of the top thing came from the other one. So they evolved from the bottom fossil. So, that's another question. Antibiotics. There's a question about antibiotics and how they, bacteria are resistant. Ask yourself this. Can bacteria, or can any organism for that matter, learn how to be good at something? Can an organism want to change? The answer is no. An organism can't want to change. It can't, learn how to become resistant to antibiotics. So, it's a natural, and it's natural selection. It's a natural thing that had occurred within the population, and again, it was a favorable trait, so it was passed on. For the bacteria, it's the very first example I gave you guys in class. For the bacteria, there were some bacteria that were resistant to that antibiotic, and so they're the ones that survived, passed that on, and so on and so on and so on. Gene frequency. If there's a gene frequency for a particular characteristic in a population that is high, and it's a good thing, it's going to stay high and be passed on from generation to generation. More about fossil layers and what the similarity of organisms in each layer would suggest. Well, it would suggest that they evolved from each other, they came from each other. More about resistant, insects that are resistant to insect repellent. It's the same concept as with the bacteria. There was a natural resistant within the population. They passed that on to their offspring. Just a general question about the theory of natural selection. Make sure you know the different points of natural selection that we talked about in that first set of notes. It's even in your second set. It should be in both sets of notes. Again, lots of just general natural selection questions asked in different scenarios. So no natural selection forwards and backwards. More about antibiotics and the resistant bacteria. Kind of a remember the Quackers lab? There's a couple questions that not about the lab, but very similar scenario. About insects that are certain color and what happens if their environment changes and which color of the insects would survive, and you'll have to interpret some pictures like that. There's 38 questions total. Again, more natural selection Which statement best shows the relationship of the concepts of evolution and natural selection? You know, then that answer would be natural selection is an example of the major mechanism by which evolution occurs. So natural selection is again how things evolve, how things change over time. Know about the things that are on the board, the like disruptive selection um, uh, disruptive selection, stabilizing selection, all those different graphs. So remember, if the two extremes of a trait are doing good, then it's disruptive selection. If it's the middle trait doing good, like the average of the trait doing good, then it would be disruptive, or I'm sorry, stabilizing selection. How does natural selection produce change? That's another question. Natural selection operates extremely rapidly to develop advantageous traits in. So when would it, what's an example of when natural selection could act rapidly? Does natural selection act on populations or individuals? Populations. That's really about it. It's just a lot of different avenues to ask about in general, natural selection and things we've covered in class. Speciation, there's a couple graphs on speciation, be able to interpret those. So I don't think it's going to be too difficult. As I've always said, I will be in the class tomorrow morning. Don't really have anything going on in the morning, so I should be there if you have any questions or just want to kind of look over things or go over your review. So sorry this is a little bit late. Caden Colt had basketball practice, so I was doing my daddy duty. So y'all have a great night. See you tomorrow.